Did you know that most companies are wasting thousands of dollars on underutilized servers? Imagine running multiple systems on a single machine, saving space, energy, and costs. Sounds impossible? That's where server virtualization comes in. In this video, we'll break down how virtualization transforms physical servers into powerful, efficient virtual machines, and how it can revolutionize your business. Whether you're managing a small office or a massive data center, this is the game changer you've been waiting for. Ready to unlock the future of server management? Let's dive in. Virtualization. Cloud computing is the use of computer servers as a service by cloud providers. So, the word cloud is often used as a marketing word that is a bit of a buzzword. In this course, we're going to talk about physical server virtualization, and what a network topology looks like, managing in the cloud. Before server virtualization, there were only physical servers that ran a single operating system, such as Microsoft Windows Server or Linux. This dates back to a time when processors only had 1 or 2 cores and didn't have much RAM either. A server is very similar to its own personal computer, except that it is designed to run 24/7. Generally, servers have more reliable hardware and are even equipped with multiple power supplies and hard drives to ensure perfect redundancy. There are different forms of server. The 3 that are represented here are servers used mainly in offices. This type of server has a single operating system and can be used for 1 or more applications. For example, for small businesses, the Microsoft Small Business Server product has always been a very popular office solution because it allows you to offer several services on 1 or 2 physical servers. These services can be 1 directory service, 1 DNS server, 1 mail server, 1 web server, or even 1 file server, and all this grouped together in a single server. So, in principle, it is more common to see in companies that a physical server is used for each of the roles. 1 server for the web, 1 server for DNS, etc. In data centers, as physical space has become very expensive, it is therefore more common to see rack servers like this one. And rack servers are placed in server cabinets. This is what a rack server, which is installed in a server cabinet. Later came servers blade that allow you to offer more computing power and memory while using much less space. In the image, we can see several blade slots that fit in a server rack. The blade servers have processors, memory, as well as storage, and are inserted directly into the blade boxes. Over the past decade, the number of cores in a single processor has grown very rapidly. We went from single-core processors to dual-core processors, then to quad cores, and now there are even processors with more than 10 to 20 cores. There is even a technique called hyper-threading, where we have 2 virtual cores for each physical core. This allows the operating system to use CPU resources more efficiently. Here is an example of the processor of my PC, which is an Intel Core i7. We can see the 6 physical cores and the 12 virtual cores, which can also be called logical cores. For 1 physical core, we have 2 logical cores. Today, the amount of RAM has also increased a lot. A physical server, which runs a single operating system, usually has much more CPU and RAM resources than it consumes. This is why server virtualization is widely used. It is a process that allows multiple virtual machines to run on a single physical server. All the equipment of the VM, virtual machine, is virtualized. That is to say, its CPUs, RAM, hard drives, network card, etc. For each virtual machine that we create, we can decide the number of CPUs or RAM to be allocated. Server virtualization software, which runs on the physical server, cache, is called the hypervisor. The hypervisor is what manages the virtualized server and allows you to configure the amount of RAM, Azure's, CPU, Azure, and disk space, which you want to allocate for each virtual machine. VM, virtual machine. Here's what a physical server running a single operating system would look like. Here, the server runs a single operating system and application. And here's what a VM structure would look like. Here we have in addition the hypervisor, which allows you to manage all the virtual machines that run their own operating systems. Among the few companies that offer server virtualization solutions, we have VMware, Microsoft Hyper-V, Citrix XenServer, and Red Hat KVM. All of these companies that allow virtualization offer the possibility of automatically creating and moving virtual machines from one hypervisor to another. So, what you need to know with this type of system is that if the physical machine that hosts the VMs fails, well, all the virtual machines fall at the same time. Physical servers have one or more network interface cards, NICs, that are all connected to a switch. So, one might ask, what about virtual servers? Well, virtual machines have virtualized hardware, and that even includes their network cards, which are called Virtual Network Interface Cards, VNICs. Either way, you have to connect these virtual network cards to your own network anyway. Well, that's done with a virtual switch. Seen from the inside, here's what it looks like. In this diagram, we can see that the VMs each have a virtual network adapter, VNIC, connected to a virtual switch, which in turn is connected to a physical switch through the physical network adapter of the server on which the hypervisor is running. There is therefore only one physical network card, but in principle, on networks in production, you will be able to find several physical cards in order to ensure redundancy and increase the bandwidth of all virtual network cards. The virtual switch is provided by the hypervisor vendor. It is also possible to use an external virtual switch, such as the Cisco Nexus 1000 TVV. This allows you to use the same features as the physical switches on your own network. We just talked about how virtual machines are connected to a physical switch through a virtual switch. We will now see what it looks like in a real data center, where there are plenty of racked servers. We will study the two most common rack designs, TOR, top of rack. The top of rack TOR concept has network switches at the top of each cabinet or at the top of each server rack. The servers are located under the top of rack concept switches, and for redundancy reasons, they are even connected to the two TOR switches. The TOR switches are then connected to the switches in the distribution layer. One of the advantages of this configuration is that most of the cables stay in the same rack. The only network cables that leave the rack are those that run from the TOR switches to the distribution layer switches. And the downside to this concept is that you need multiple TOR switches, and depending on how many servers there are in the rack, well, the TOR switch ports may not be all used. EOR, end of row. And in an end of row design, which means at the end of the line, or at the end of the row, there are no more switches in the racks, and all the servers are directly connected to the end of row EOR switches that are located in a separate rack. The advantage of this setup is that you don't need as many switches, and therefore, there are fewer unused ports. And one of the downsides is that you need a lot of cabling between your server racks and the racks where the EOR switches are located.